Let's go ahead and take a look at finding the domain of a log function. Keep in mind when we're working with these log functions, our argument, which is where this x is located, right? That slot always has to be something that is greater than 0. So let's go ahead and take a look at part A. If we want to find the domain of log base 3 of x minus 2, then we're going to be looking at this x minus 2 piece. And this has to be something that is greater than 0. So we can go ahead and add the 2 to both sides. So our x values for this function have to be greater than 2. And if we want to write that with interval notation, this would be the same thing as saying we would have a domain from 2 to positive infinity. Let's go ahead and take a look at part B. We want to find the domain of log base 2 of x plus 3 in our numerator and x minus 1 in our denominator. Okay, so this whole piece has to be something that is positive or something that is greater than 0. Okay, so this is going to give us some good review as we go back to working with our rational functions. Okay, we want to know when it's greater than 0. We're going to need a couple pieces of information here. We need to take a look at our intercepts, and we need to take a look at our vertical asymptote. So let's go ahead and start with the vertical asymptote. We can set the x minus 1 equal to 0. That's our denominator. And solve this. We'll get an x value of 1. And let's go ahead and take a look at our zeros, or our x-intercepts. That's going to come from our numerator being set equal to 0. And this is going to give us an x value of negative 3. So let's go ahead and plot these on our number line. We'll take a snapshot of the x-axis. So we've got negative 3 and 1. And this is going to divide up our graph into 3 sections, 3 intervals. We've got A, B, and C. Okay, and let's go ahead and do a test value for each of the intervals, and we'll see if our function is either positive or negative, so we can take a look at where it's either above or below that x value. So let's go ahead and start with an x value of negative 4. If we plug this into our function, negative 4 plus 3 is going to give us a negative 1 on top. And in our denominator, we're going to have negative 4 minus 1, which is a negative 5. This is going to give us a positive 1/5. Right? So in this interval A, these values are going to be positive or above our x-axis. Let's go ahead and take a look at interval B. And let's go ahead and use an x value of 0. If we plug that into our numerator, we've got 0 plus 3, which is 3. And in our denominator, we've got 0 minus 1, which is going to give us a negative 1. So this will simplify to a negative 3. And that means we have negative y values here, or values that are below our x-axis. And let's go ahead and take a look at our last interval. Let's use an x value of 2. So we'll have 2 plus 3 in our numerator, which is a 5. And 2 minus 1, 1 in our denominator. So this will simplify to a 5, which is a positive number. So these values should be above our x-axis. And we want to know when it's greater than 0. So we're looking for those spots where it's above. So we're going to have 2 intervals here for our domain. We've got the interval from negative infinity to negative 3. And we have the interval from 1 to infinity.